Welcome back, everybody, to the last week of class. Going to be marking everything this week, so make sure you're handing your stuff in, and mostly the marks are just going to be based on the labs. We've only had one or two assignments, right, and one test. Did we even have one test? I can't even remember, but it should be easy to get those labs in. Make sure your Pong game is in as well. Today we're going to be talking about two things that we haven't talked about before in this class. One is called arrays, and I'll talk about that one first. And then the other one is random numbers, which they're both pretty straightforward, easy topics. An array is when you make a variable that will hold a whole bunch of data instead of just one item. And that could be really useful. For instance, let's say I'm making a program to keep track of this class, okay? And so I'm going to make a string variable called names, right? And I want to set the first, maybe I want whoever's using the program to be able to type in the first name, okay? So we'll go something like that. And then I could save it and later on, whatever, put their grade on the screen or, do something. So let's see what that looks like. And it doesn't prompt for anything, but maybe someone's name is George in the class. Okay, fine. Then the next student comes along, and I gotta kind of call this one names1 and see in that, right? And then I gotta make another string called names2, and it's kind of a superfluous way to do it. I don't really need to make all of these variables. Let me just open my debugger here. There we go. Run it. That's how you run the debug, by the way. I don't have a little stop sign anywhere, though, so I'm just going to put one right there. The debugger should work really well at home for you. For some reason, it doesn't work on a lot of the student computers at school, but there we go. Grog, George, and Gorf. Those are the three people in my class. Does the debugger stop? Yes, you can see this little yellow line, meaning it's stopped on that line waiting for you to do something. You can do tons of stuff with it. You can look inside the memory, and you can really dig deep to what's going on. What do I always look at? Memory dump? You can look at memory in the computer and stuff. It's kind of neat. Obviously, I can't. Oh, I can look at a memory by pressing the ampersand sign and then names2, and it'll tell me what's in the memory. These are all the little bits and bytes inside the computer, and it even knows it says the word Gorf in there. It's not super good at detecting if it's a string or a number or whatever, but it can. I think this can be kind of useful sometimes, kind of neat. But I like to always look at watches, because then it'll show you what your variables are doing. And then you can step through the code a line at a time. Sometimes it can be really useful to catch little mistakes that you just can't figure out what's going on. But there they are. All my variables, great. So that's not a great way to do it, though. Actually, the best way to do this, because I'm going to have 20 kids in a class or something, is to write names. And then in square brackets, how many you want after the names. And then it's just a matter of making a for loop. For loops and arrays go hand in hand because the array will store as many integer numbers as as many different items as you want. It's always an integer, right? I could store 10 things or 20 things, or I can't store 1.5 things. That doesn't make sense. And so arrays and for loops go really well together, and then I could just do something like C in names like this. And then I would put I there, okay? And then it would count all of the different arrays. So before I do this for loop, actually, let me just show you how I would CI in all of these if I wanted to do it that way. Oops. For some reason my tab is messed up here. C in, and then if I want to do the first one, I write the word names, and I write a 0 after it. C++ always starts on 0. Seems weird for arrays. They're indexed at 0 first, and then I could do the second one, and then I could do the third one, which is actually 2. That's why a lot of our for loops always start at 0 as well, because of this fact, actually. And so on and so forth. But again, I'm just going to stop my debugger here. That is awkward because I haven't really saved too much code. I mean, I don't have to make a new variable every time, but I'm still C-inning with all of this code here. So let's see what happens here. Let me just debug it again here so I can show you what it looks like in the memory. They'll all be a row in the memory. So Franca, Frank, and Frederique. And I need one more. Dan. Okay, and there we go. If I check my variables, you can see I only have one variable now, which is nice, and it has 20 things in it, from 0 to 19, so I can look at it in the debugger, but only the first 4 are full. And if I want to access them, I just access them with little square brackets. Okay. So, if I make a for loop, int I equals 0, int I equals 20, and I plus plus. Okay, and then I just write names I, but I C in it. Then I can get all 20, which would take forever, and I'm not going to do it. Maybe I will. The heck. It's a YouTube video. I'll just go real quick. Ooh. I don't need int here. And I need I is less than 20. Just woke up. CIN names. For some reason I have a period on the end of that. Okay, my first name is going to be A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, and T, and U. And there we go. Oh, I forgot to debug it. I wanted to look it all up in the memory. Let's do it really quickly. Fast forward this. If I press nothing there, it doesn't count as one, by the way. There. Stopped it. Checking the memory. I filled them all up with the alphabet. And the one I missed, the little blank, it didn't count it. Okay? Cool. So that is how you do arrays. They're very, very useful. Okay, especially in graphics. Let's say we want to draw like 50 things on the screen, right? Do we need to make 50 variables if they're all going to be circles bouncing around or something like that? No. We would make an array, and then we would use our window.draw command, but we would put it in a for loop, right? And we could draw like circles I or something like that, and that would be in a for loop, and it would draw all 20 of them wherever we had them set up. So interesting. Arrays are cool. A couple of limitations of arrays is you always have to set the size when you make it, so it can't be variable. Like, well, you could put a variable in there, like int num1 or something equals 20, like that. But you really almost have to know what it's going to be before you run your program. But let's say you're running a program that's going to open a file and add all the students to the class, and the file already has the students. How is array going to know how many students you have in your class? 'Cause it can't really change that on the fly. So we'll learn a way to deal with that. Okay. The other thing is, let's say I have 20, right? And they're in the memory of the computer, and let's say a student gets added 2 weeks into the class. How do I deal with that? Like, can I all of a sudden just add something in here? And the answer is no, actually. This array is just 20 times 4, so 80 bytes of memory all in a row. And right here you said you're going to need 80, and the computer doesn't know how to deal with how to just pop one in there. So there's another type of variable type that will allow us to do that. They're called containers. They're identical to arrays in almost every way, except they're a little more flexible. But arrays are still useful for us right now. Okay, so check that out. The other thing I wanted to talk about today is random numbers. To include that, you need this library, and it's called the C standard library. CSTDLIB. I think that's it. will that allow me to use this command? Let me quit this. I don't want to type in 20 names before I run my stuff. So I'm going to see out the command rand. Did it let me do that? Let's see. Yes, it does. It output the number 41. Now I'll run it again. 41, 41, 41. Weird, eh? That doesn't appear to be too random. Let's output 20 random numbers and just see kind of what's going on here. So I will make my loop from 0 to 20. And I'm just going to output random number. I don't need brackets because there's only one line of code in that for loop. And there you go. So it did put 41 again, and then 18,476. It looks like it, I don't know really what the range of this is yet. I'll find out. It doesn't look like there's any negative numbers, and if there were statistically any, we would have seen some by now. So I'm guessing the lowest random number we can get is 0. What the highest number is, I don't know. We'll find out. But that's how you output a random number. So let's just quickly look at these numbers and watch what happens when I run it again. It does the same thing again. Okay. So computers are not super good at being random. It can like spit random numbers at you, but it spits them out every single time the same. Okay. So that could be really awkward if you're playing a game that relies on randomness and you're getting the same random numbers every game. So here's how you deal with that. You write the function srand, okay, only once in your code, usually the first line of your code. And then you give it just some random number, and this is kind of like the seed where it like tells your computer to randomize your random numbers based on a random number you pick. But you obviously, so now they're different. Do you see that? Obviously, every time you run your code, you can't just hammer in some random numbers here, right? And if this number is always the same, like let's say I put number 1 in here, I get the same numbers I got the first time I ran it. And if I put the number 2, let's see what happens. Computers are really not good at being random. They're almost like, you know, they're good at not being random. Obviously, if a computer was random, then you'd have major issues with it. So how am I going to make this kind of a random-ish number automatically? What I will do is I will write in here. Let me see if this command works. It might not unless I add a library. If I write the word time and I write the word 0, it doesn't work. It's never heard of time. So I'm going to include this time library as well. Time.h. There you go. And what time is let me comment all of these out for now, is the time on the clock on your computer, and I think it outputs like the number of seconds since 1970, January 1st, something weird like that. It's a big number. What is that? It's 1.6 billion, right? And if I press it again, it'll be close to this, but it'll be a little higher now. It'll be like 150 or something at the end there. 153. Do you see that? But it is random enough that it'll give us completely random numbers every time we run it, our program, right? It's a random time for us. Essentially, it's the time your finger presses F9, and that's a random enough number that this is kind of like our, if I could give an analogy of how this works, is this pulls a card off of the deck, of a deck of cards for you every time you run it, okay? But that deck of cards is really big. So we're going to find out how big it is, what the biggest number is. But let's say I have a deck of cards that has 30,000 cards in it. So I'm going to pull off a random card, but the deck is always in the same order every time I run my program, which isn't good. So what this does is it shuffles that deck. Okay, this srand command does it. but it shuffles it very specifically based on whatever number you put in here. So if I could put in a number that's even semi-random, which the time on the computer is because I'm pressing F9, and that's kind of a random, like the second I press that is a little bit random. I mean, if I ran this program every second, exactly once a second, if I had some program that ran this program once a second, then this would not probably be too random, because I would be shuffling that deck exactly every second, and it would probably introduce some sort of order in my program. But for now, this is definitely good enough to introduce randomness in there. So there you go. I'm getting random numbers every time. Now, they're close to each other sometimes. Like this number seems to be always 12,374. Now it's 12,394. It's climbing a little bit, but I mean, that's good enough for us. There's ways to get really crazy numbers in C++, but every other number seems to be very random from itself. Like this number was 15,000. Now it's 11,000. So they're all off by one another. So cool, here we go. How am I going to figure out what the biggest random number is? Well, I'm going to make a number, okay, called biggest, a variable. I'll set it equal to 0. I am going to run this for loop. Okay. I'll also make a variable called r that will hold in a random number. So I'll say r equals a random number, like that. Okay. And now what I need to do is, these brackets are all messed up. It's going to bug me. Is say that if r is ever bigger than biggest, then make biggest equal r. So biggest starts at 0. Let's say r is 5. Well, if r is bigger than that, then my biggest number is now going to be 5, and then so on and so forth, and so on and so forth. So I'm going to run this 20 times, and then I'm going to see out biggest and see what's the biggest number it grabbed out of my list of 20. 30,828. I'll run it again. 30,000 what? It looks like it's close to 30,000. Okay, let's run it 200 times. It runs it really fast, so 32,744. It looks like it's going to be kind of close to 32,000. 32,746. What's one of those numbers to the power of 2? It's one of these famous 2 to the power of, I think it's 16 or something. That would probably make sense because it is a computer. It likes everything in powers of 2 because binary has a 0 or a 1 switch. So 2 to the power of 16 is what? If I divide that by 2, 32768. I think that might be the biggest number. But let's keep running it. We'll run it 2,000 times. Maybe it'll catch the biggest number. 3,274. What did I say it was? 32,768. Sorry. Just quickly check that one more time. 2 to the power of 15, right? 32768. Let's run it 2 million times. The computer is fast enough to do that. There's 200,000. There's 2 million. Chances are 32767. Is that 32768? No, but 0 counts as a number, so it's going to be 1 less than that is my guess. And if I run it 2 million times, the chances that I hit that number are pretty good. If I run it 20 million times, the chances are probably almost 1 that I'm going to grab that biggest number. 32767, yeah. 32767. It's taking 0.3 seconds to run it, by the way. Yes, 32767. Good. Run it. Yes, 32767. So that is the biggest number. And that's how you do it. That's how you check, anyways. One of the ways to check. Here is how you get random numbers to be between ranges that you want. Let's say I want a number between 0 and 9. I just hit %10, our good old remainder function, right? Any random number that divides by 10 will have a remainder between 0 and 9, right? So if I look at the number 0 and I divide it by 10, its remainder is 0. If I look at the number 1 its remainder is 1, right? Because it doesn't divide by 10 at all, and so on and so forth, all the way up to 9. 9, if I divide by 10, has a remainder of 9, doesn't divide. 10, though, has a remainder of 0. It goes in evenly. 11 has a remainder of 1. 12 has a remainder of 2. Do you see how it just keeps climbing from 0, 1, 2, 3, all the way to 9? Okay. So if I want a random number between 0 and 10, let me just delete all this code, and I will do rand percent 10. Oopsie. You never put anything in the brackets for rand. Then this will just give me a bunch of random numbers between 0 and 9. I'll just run it 20 times to see what they look like. Yep, all numbers between 0 and 9. But let's say if you have a dice game or something, right? And you want numbers between 1 and 6. Well, if I press %6, that should give me numbers between 0 and 5. Right? Similarly, just like the way 10 did. And I could say, well, 0 is 1 and 5 is 6. Or I could just say plus 1. So this is a random number between 0 and 5. And then if I add 1 to it, I'll get a random number between 1 and 6. Makes sense? Oops. So this could be my dice game now. Yahtzee. Great game. Okay. There's 20 random numbers between 1 and 6. What if I want a number between, here's something weird. Like, let's say I want only numbers between 5 and 13. Okay. What I have to do is I have to figure out how many numbers are between 5 and 13. And the answer is not 8. It's actually 9 numbers between 5 and 13. Count them up in your head and convince yourself of that. Okay, it's 5, 6, 7, 8, 9, 10, 11, 12, 13. That's 9 numbers. The first number counts as a number. Okay. So if I wanted to do that, I would need %9, correct? Instead of %8. Or I could say something like %13 minus 5 plus 1, right? If these were variables. But I'm just going to put 9 so I don't scare you. And then I'm going to say plus 5 because this will give me a random number between 0 and 8. And then if I add 5 to it, I'll have a random number between 5 and 13. Okay. So there's 20 random numbers between 5 and 13. Okay, so there you go. Random numbers and arrays. Work on those two today. Email me any questions if you want. I'll be on the Google Classroom at 11, or Google Meet at 12, 1, and 2 if you need help. Excuse me. And yeah, leave a comment, say you watched it. The last day of class, maybe the last 2 days, we'll just work on catching up on anything you don't have done. And that'll be a wrap on the class. We'll learn a few more topics. You don't need any graphics for this, so if you don't have graphics at home or you're working from a Chromebook, you can still do this code. Okay? We'll talk to you tomorrow. Bye now.